All right, everybody. Welcome to 6.3. We are going to start talking a little bit about similarity here now that you've gotten some background on, or remembered some background at least, on proportions and ratios and all of those good things. This particular note sheet starts out with an activity that I would highly recommend that you do. It's going to help set up some things and help you see some things that if you see the words by themselves will make less sense than if you see what's going on here. This one does have something in it where it says you could have a partner. If you do have a partner, you're going to have to do about half of the work that you would have to otherwise. But you can do it alone if you want to. What you're going to need in the end is you're going to need two differently sized triangles that are following the directions that are right at the front of your note sheet. You'll also need a protractor. And like I said, if you have someone with you, you're going to have to do half the work that you would otherwise. So you may want to find someone else to do this with. But I would highly recommend starting with this activity. I think it's going to help you see some things. Just follow the directions and then fill in this chart that's here. You'll notice that you have to fill in the side lengths of your triangle, the perimeter, and the area of your triangle. Remember, area of a triangle is 1/2 base times height. So you may have to measure a length to find the height of the triangle as well. You're going to then have to find out the ratio between your and your classmate's triangle. Write it as decimal. And you're going to be asked to answer some questions down here below about this situation, all the way down to here. So I would recommend doing this first, and then I would move on to watching the rest of this video if I were you. I think it would be a good thing for you to see. The words will make more sense if you actually see it happen in practice. So I'm going to pause here for like 5 seconds, giving you time to pause. And then once you've done the activity, I would then recommend watching the rest of this. Okay, so hopefully you did the activity. Hopefully you were able to answer these questions and realized a few things. For one, you probably realized that the ratios of the perimeters compared to the ratios of the side lengths were the same. And you probably noticed that the ratios of the side lengths of your two triangles were also the same, which is really, really important because, obviously, if you were following the directions that I said earlier, your triangles aren't the same size, but these ratios are consistently the same. And that right there is the big difference between congruent figures and similar figures, because your triangles should be similar. Congruent figures have the same side lengths and the same angles. But your shapes, your similar figures, they have the same angles, as you probably noticed when you made your triangles, but their side lengths are different sizes. So yeah, that is the difference between congruent triangles and similar triangles. So, as it says at the top of the second side of your note sheet, two polygons are similar if corresponding angles are congruent and corresponding sides are proportional. And what proportional means is it means two equal fractions. Now, like I told you, similarity is related to congruence in a way, because they, some aspects are the same, the angles are the same. And you'll remember that the congruency symbol is, and don't write this down quite yet, is the squiggly line with this equal sign below it. Well, similarity is based on that. It's the same thing, but without the equal sign. That is the symbol for similarity right there. So, because they are related, congruence and similarity, some things are going to look very, very, well, similar. Here, we have a similarity statement, which is kind of like our congruency statements that we used to have. And remember how in congruency statements everything lined up? Well, it still lines up in similarity statements. So corresponding angles, we know that angle A corresponds to, which in this case means it's congruent to, angle D. And the way we know that is because here's A, here's D. They're in the same position in our similarity statement. We can also say that angle B is congruent to angle D, angle E. And we can also say that angle C is congruent to angle F. Corresponding sides are going to work a little bit differently. Basically, if we're told that we have similar shapes, what we can do is we can set up, with our corresponding sides, ratios. Instead of saying AB is congruent to DE, what we'll be able to say is that AB over DE, and this is where the proportionality comes in, is equal to, then we bring in our second set of them, BC over EF, and notice that I'm putting all the ABC ones on top, that's important, which is equal to AC over DF. So AB is not equal to DE, but if we take AB divided by DE, those lengths, it's going to be equal to BC over EF, which is going to be equal to AC over DF. So that's how similarity works. This, by the way, is a statement of proportionality, because we are showing how all of these sides are proportional when we look at them matched up with each other. So, the example down here. These two polygons are similar. Find the value of f. Well, or of x, I'm sorry. So we know that ST here is congruent to PQ, or not congruent to, similar to PQ, which means that we'll be able to set those two up in a proportion. Let's start with ST, which has a length of 6, and we'll put it over PQ, which has a length of 4. Matching up two more sides that are similar to each other and are corresponding, the 6 comes from the ST triangle, so we're going to start with SU on top for this one, over our missing side of PR. So now we just use cross multiplication, and we're going to get 6x equals 4 times 12, which is 48. Divide both by 6, and we get x equals 8. In this one over here, we may want to carefully examine what sides match up with what. Here we know that DE matches up with MJ, and we can see that this is a rectangle. So if this is a length of 8, so is this. This is also 12. So what you should notice is that MJ is matching up with this 8 side here. Now, they're not congruent, but what that means, and we know that this is also 12, is that this 8 over here is matching up with this 12 over here. And this MLX, this X as the length of ML, is matching up with CE. So this is how we're going to set this up. Let's start with the left triangle this time. We have a length of 8 for DE, which is matching up with MJ, which has a length of 12. So we also know that CE in the first rectangle has a length of 12, and we are looking for the length of ML. So what this leads to then is 144 equals 8x. Divide both by 8, and we get x equals 18. So there's that one. And here we have some further examples that are looking at this whole idea. Find the scale factor of BCDE to WXYZ. So what we want to do here is find a side that matches up. And if you look, we can see that BC matches up with XW right there. We know that BC has a length of 4, and XW has a length of 6. So if we wanted to reduce the scale factor, we can divide both of those by 2, and we would get 2 to 3. Scale factor of going the other way would just mean switch the numbers. We have 3 to 2 for that one. If we're asked to find what xy is, well, here's xy. Looking at this, xy is going to match up with CD. We know that CD has a length of 3. This is the one we're looking for. So we can use our scale factor at this point. Let's say that we want to put the x, well, it doesn't really matter where we put it. Let's use the scale factor that we found from number 7 and use 3 over 2. Well, remember, that means that we're putting the WXYZ value on top. So 3 over 2 is going to equal x over the value it matches up with, which in this case, CD, is 3. So we get 2 equals 9x. Sorry, that is not correct. Using cross multiplication properly, we get 2x equals 9. Divide both sides by 2, and we get x equals 4.5. So that's the length of xy. Measure of angle C. Well, we know that angle C matches up with angle x, and angles in similar shapes are congruent. So if x is 117, then C is also 117. To find the quadrilateral of XWYZ, we know that we found this to be 4.5 over here. This one is also 4.5. We're given that this one is 6. And what we would need to do is use the scale factor to turn this 6 to find out what this missing length is. If you were to solve it, you would figure out that it was a length of 9. 4.5 plus 4.5 is 9. 9 plus 9 is 18. 18 plus 6 is 24. And I kind of skipped the step of figuring this one out, but you would do something similar to what you did in number 8 to figure that one out. So that is this video. That's the beginning of the idea of similarity. There is a homework assignment for this one, and after this you should be ready for the mid-chapter check-in, and that is your practice quiz basically. So try out those problems and see how you do, and then we'll work from there. Good luck. And the next video that's coming out after this one is going to be on 6.4. See you there.